Start streaming, and here. Let's see if I am live. Captain's music. Hi, Captain. Okay, I cannot see myself live. Let's check again. I believe I'm live. Okay, I cannot see myself live. Okay, so you saw my. All right. So I am live. Yeah. Sorry. So yes, we are live now, guys. And here we are. So let's get started. As you guys know that this is your Unacademy, ISC and ICSE channel, and we are going to ace in your term 2 examinations with Unacademy Plus, right? So let's talk about me. I am your chemistry educator, Kirti Sharma. As you guys know, I have done my graduation from University of Delhi, and I have more than 5 years of teaching experience, and again I have taught a lot of cute and smart students like you. And now it's your turn, right? So simply say hi in the live chat so that so that we can be friends, correct? So let me know, guys, who is here to watch the session. Let's begin. Let's get started, okay? So what are we going to study today? We will see, just give me a moment. Oopsie. I need to put it again. So what are we going to do today? We will start with oh, what happened? Okay. Yeah. So here we go. Let me turn it on. So what are we doing? We will discuss surface chemistry today. All right. There is again some, although I just redid it. It has to be done. Okay. So we will be doing, we just, हम यहीं पे अटक जाते हैं. Okay. So we will do surface chemistry today, lecture number 3 this is, right? This is our lecture number 3. Lecture number 4, I believe, right? It is lecture number 3 or 4. Just let me check whether it is... yeah, now all set. Now I can use my pen. Okay, so this part was done. Yeah, so what are we gonna do today? We will study surface chemistry. We will study surface chemistry. Okay, it takes a little bit of time to get adjusted here, so that the pen is working, the camera is working, the whole system is working, right? So we will do surface chemistry now, and this is our lecture number 4, right? This is our lecture number 4. Today we will mostly we'll study about colloids, okay? Like how are they differentiated, on what basis, what are the types of colloids, that we will do today. And one more thing is that if you guys are planning to take the Plus subscription, then it is amazing, because another batch will be launched on 17th of January. The name of the batch is Mavericks, and in that batch again, hi Pragati, how are you? So in that batch, what are we going to do? We will cover our 100% syllabus. Some of the students have already joined, so you guys can come here, join the session, make your friends, cover your 100% of the syllabus. So like, it's so much fun. So you can just simply use my code that is Kirti S Live when you get the subscription, and you will get 10% discount. I don't get it. Why, Pragati, like you delete the message? Once I read it, you erase, you remove it. Is there any reason for that? Any reason? Of course, I remember you, Pragati, Pragya, sisters, cute sisters. I remember everything, okay? Alright. I remember all my students, alright? So, yeah. So, follow Unacademy Champions on Telegram. The link is given to you in the description box. And don't forget to subscribe us on YouTube. So, let's get started. Alright. This is your habit. Very strange, huh? Okay. So yeah, where were we? In the previous session, we left here from here. So we will like start from here. Okay. So now it is promoters and poisons. Okay. So we already know what are catalysts, right? We already know what catalysts are. So see, if a reaction is happening, so the catalyst won't take part in that reaction, but catalyst, they enhance the speed of the reaction. Basically, catalysts can be used for both the ways. One is to increase the speed of the reaction, and the other one is to decrease the speed of the reaction. But generally, like you can say 99% of the cases, we use catalyst in order to increase the speed of the reaction. Okay, so the next thing is promoters. It is promoters and poisons. Now if you want the activity of catalyst to increase, you want to increase the activity of catalyst so that catalyst will increase the rate of the reaction. So basically, your promoters also enhance the activity of the catalyst so that the catalyst will work even faster, and as a consequence, what will happen? The reaction will happen quickly, right? The reaction will happen more quickly, I would say, right? So you can say that promoters are substances that enhance the activity of a catalyst, while poisons decrease the activity of the catalyst. So promoters and poisons, two different things, okay? For example, in case of Haber's process, which is used for the production of ammonia, right? Haber's process is used for the production of ammonia, that is NH3. So you can see here N2 plus 3H2 gives you 2NH3, right? So here you can see iron. Iron here is used as a catalyst. Iron here works as a catalyst. Whereas molybdenum, it works as your promoter. It works as promoter. यानी कि when you even like add molybdenum, it it increases the activity of the catalyst. So it works as promoter. So did you guys understand the difference between catalyst and promoters? Because sometimes the students are like, ma'am, isn't it one and the same thing? Both are used to increase the rate of the reaction. But no, catalyst is used to increase the rate of a reaction, and your promoter is used to enhance the activity of catalyst. So in short, like as a consequence, your reaction will happen faster. Okay, so as you can see here, in the production of ammonia, when you talk about Haber's process, what happens? When you take Fe, that is iron, it works as catalyst, and molybdenum works as a promoter. Okay, let's move on to the next thing, that is homogeneous catalysis and heterogeneous catalysis. So we discussed like what is homogeneous catalysis. Where is, right here. Just give me a moment, I'll just close it. Yeah. Let's talk about homogeneous catalysis. If we talk about homogeneous catalysis, so what happens is that your reactants and catalysts, your reactants as well as your catalysts, they are both in the same phase. They are present in the same phase, okay? Whereas in the case of heterogeneous catalysis, like in the homogeneous catalysis, you can say that if the reactant is if the reactant is liquid, then the catalyst is also in the liquid form. If reactant is like in the solid form, then catalyst is also solid. If the reactant is in the gaseous form, then the catalyst is also in the gaseous form, okay? That's what you call as homogeneous catalysis, okay? And what is heterogeneous catalysis? If we talk about heterogeneous catalysis, then what happens in case of heterogeneous catalysis? Your reactants and catalysts. Your reactants and catalyst they are in the different phase. They are in different phase. They are in different phase, okay? Say if your reactant is solid, then if your catalyst is say in gaseous form. So what happens? This case is known as heterogeneous catalysis, okay? This is known as heterogeneous catalysis. So that is like we have been given some examples of homogeneous catalysis and heterogeneous catalysis. So let's look at them. It says when the reactants and catalysts are in the same phase, same liquid or gas, the process is said to be homogeneous catalysis. The following are some of the examples of homogeneous catalysis that we can see here. The very first one is the oxidation of sulfur dioxide into sulfur trioxide. That is, like sulfur dioxide is SO2. You added oxygen to sulfur dioxide, right? Whenever you add oxygen to something, it is known as oxidation, right? So 2SO2 plus O2 gives you 2SO3, right? This is an example of your heterogeneous, sorry, this is an example of your homogeneous catalysis, right? Why is that so? Let me know in the live chat, why is this an example of homogeneous catalysis? See, the reactants are present in the gaseous state, gaseous, and when you take NO, it works as a catalyst and it is also present in the gaseous state, right? So the reactants and the catalyst, they are present in the same phase. That is why they are being called as, this is the case of the homogeneous catalysis, okay? Now see, as you can see, here is your explanation as well, which says the reactants sulfur dioxide and oxygen and the catalyst nitric oxide, that is NO, they are all in the same phase, that is gaseous. In which phase they are present? They are present in the gaseous phase, okay? Now another example can be hydrolysis of methyl acetate is catalyzed by H positive ions furnished for hydrochloric acid. So as you can see here, your methyl acetate CH3COOCH3 in presence of H2O, in presence of water, and in presence of HCl, right? So you can see that all your reactants, that is your methyl acetate and water, present in the liquid form, as well as HCl, which is behaving as a catalyst here. It is behaving as a catalyst here. So it is also in the form of it is also present in the liquid form. That is why you are saying that it is again a case of homogeneous catalysis. It is a case of homogeneous catalysis. I believe there is no doubt. Let me know if there is any doubt. Okay. Now, if we say about heterogeneous catalysis, so we know when the reactants and the catalysts are present in the different phases. In that case, it is known as heterogeneous catalysis, right? So you can see the examples. When sulfur dioxide is converted into sulfur trioxide, so here platinum is working as catalyst, right? But you can see here that sulfur dioxide, that is SO2, and sulfur trioxide, that is SO3, these are present in the gaseous state, whereas platinum, which is working as a catalyst, it is present in the solid state. All right, just give me a moment. Yeah, okay. Let me know, bacha, in the live chat if you have any doubt. Okay. So the next thing is, the reactant is in the gaseous state while the catalyst is in the solid state. That is why this is known as heterogeneous catalysis. Okay. Another example can be combination between dinitrogen and dihydrogen to form ammonia in the presence of finely divided iron, in presence of this is your Haber's process again. So here we are not using molybdenum. What we are using? Shaista. Okay, very different name. Hi beta, how are you? So yeah, here you can see that you are using iron in a finely divided particles. I told you that in case of adsorption, what happens? The more surface area which is available, so that more gas can be adsorbed on the surface of the adsorbent, right? So in case of heterogeneous catalysis, if your catalyst is present in the solid state and your reactants which are reacting are present in the gaseous state, so that there are you can say that on the surface adsorption will happen, right? And then the reaction will proceed. Hi Shaista, how are you beta? How are you? Where are you from? Is this your first class, or have you taken classes previously as well? Let me know something about yourself. Okay, so that's what we did in case of Haber's process. Okay, so you can say the reactants are in gaseous state while the catalyst is in solid state. That's exactly what we discussed. Another example can be oxidation of ammonia into nitric oxide in the presence of platinum gauze is in Oswald's process, right? So you can see here that all the reactants, see gaseous form, but platinum is present in solid. So you see that platinum, nickel, iron, these are very good adsorbents. Okay, in some reactions they are very good adsorbents. Cool. So hydrogenation of vegetable oils in the presence of finely divided nickel as catalyst. Okay, so welcome to the class, Shaista, and from UP. Okay, that's nice. And do you have ICSE boards? I mean, like, do you have ISC boards or CBSE boards? Like, from which board are you from? Hmm. I would love to meet you in the special class as well, beta. Okay, you can just simply download the Unacademy app, go for ISC boards class 11 or class 12. You will find me there, and there you can attend free live classes. I am telling you, free live classes happen daily, okay? Almost daily. Even like two classes a day, one for class 11 and the another one for class 12. So you can join, you can come to the class, and you will be like familiar with the platform. Okay, all right, let's move ahead. Where were we? On the hydrogenation of vegetable oils in the presence of finely divided nickel. So you'll see that here we are using finely divide iron or finely divide nickel, because again the reason is, more the surface area which is present, better and more will be the chances of adsorption, right? We have already done this in our previous lectures. So you can say here one of the reactant is in the liquid state and the other is in gaseous state, while the catalyst is in solid state. So all the three states are present here, right? Something is present in solid state, a hydrogen gas is present in gaseous phase, and nickel is present in solid phase. Okay, now we have adsorption theory of heterogeneous catalysis. I told you na that in case of heterogeneous catalysis, when your reactants and catalysts are present in different phases. So basically we will generally talk when your catalyst is in the solid form, and your reactant is present in the gaseous form, so that there will be adsorption, and that is what the adsorption theory of heterogeneous catalysis says. So it basically explains, you can say, the mechanism, the process of heterogeneous catalysis, like how this process happens. Okay, what are the like steps? So in this theory, what happens, which is known as adsorption theory of catalysis, it is that when reactants in gaseous state or in solutions are adsorbed on the surface of solid catalyst, that's what we discussed. The increase in concentration of the reactants on the surface increases the rate of the reaction, right? More the gases which are adsorbed on the surface of the adsorbent, more will be the rate of the reaction. The rate of the reaction increases, you can say. Okay, now the adsorption being an exothermic process, the heat of adsorption is utilized in enhancing the rate of the reaction. Okay, so this we already know. The next thing which comes is the mechanism, which usually involves 5 steps. Okay, now let's see what are these steps. Okay, let's see what these steps are. Okay, yeah, everything going good? Yes, everything is going good. Cool. Let me see. Yeah, okay. All right. Saurav Mandal. Hi, Saurav. You come in like very few sessions. Like you come for a minute or two, then you leave, right? Why so? Okay, let's go ahead. It is like it involves 5 steps. That is your how the reaction happens. So the very first step is the diffusion of reactants to the surface of the catalyst, right? if your catalyst is present in the solid state, so the reactants will diffuse on the surface of the catalyst. Okay, now adsorption of reactant molecules happen. Now the catalyst will serve as adsorbent, and your particles which are present on the surface, they will be present. See bache, Shaista, see, chemistry is chemistry, right? Like the way adsorption happens in NCRT, it is the same way it happens in Nagin Prakashan. Okay, so the basic concepts are always the same, right? It doesn't depend on the board whether it is CBSE or ICSE, or whether you are preparing for NEET or JEE. The basic concepts, the adsorption remains the same, right? So right now we are just covering the basic concepts, the basic theories. So you will feel that everywhere it's the same, whether it is CBSE or ICSE or any other state board, whether NEET or JEE or NDA, like whichever you prefer. Okay, so these are some basic concepts, and like it will just, you can say, enhance your knowledge. Okay, so वही है जहाँ पे ज्ञान मिले ले लो उसको, right? Okay, let's move ahead. Exactly, Shaista, I liked your name, really lovely name, something like different it is. All right, so like first the reactants diffuse, they cover the surface of the adsorbent, and then adsorption happens such that the adsorption of the reactants happen on the surface of the catalyst, right? And then there will be some chemical reaction. That's how we saw physical adsorption and chemical adsorption, that the particles of adsorbate and adsorbent are held together by some force. So occurrence of chemical reaction on the catalyst surface through the formation of an intermediate. Okay, an intermediate is formed, something which is between, like, see, it does not happen directly that your reactant is directly, converted into the product. Sometimes what happens is, firstly the reactant changes into something else that we call as an intermediate, and then that intermediate forms finally the product. Okay, so that is what an intermediate is. Now the adsorption has happened, now the reaction has happened. Now what will happen? Desorption will happen, such that the desorption of reaction products, now they will leave the surface of the adsorbent, like they will leave the surface of the catalyst. Okay, so desorption of reaction products from the catalyst surface, and thereby making the surface available again for more reaction to happen. Okay, so that if like more reaction is to be happen again, so that more particles will again diffuse on the surface of the adsorbent, then again adsorption will happen, then again there will be some chemical reaction, and this will like go on till the process completes. Okay, till the reaction completes. So diffusion of reaction products away from the catalyst surface. Exactly. Hi Suraj Mandal, how are you, beta? So the surface of catalyst, unlike the inner part of the bulk, has free valencies which provide the seat for the chemical forces of attraction. This we did in the mechanism of adsorption, right? This is the same thing which we did in the mechanism of adsorption. We have done this in our previous lectures, so you guys can go and watch it. Okay, yes. So Suraj, is it your first lecture, or have you watched the lecture before as well, earlier as well? All right, so this is the mechanism of heterogeneous catalysis. All right, I believe it's done, no doubt for now. Okay, now we will start with the by here. Okay, now we will start with colloids. Okay, Okay, I welcome you, Suraj. That's amazing. Beta, we have already covered a few lectures of surface chemistry, and today's lecture number 4. We have already done adsorption, like physical adsorption, chemical adsorption, catalysis, the few things, basic things we have already done. Now we will start with colloids, okay? Alright, so let's start. So, what is a colloid? So, you can say, first of all, that it is heterogeneous in nature, in which dispersed phase and dispersed medium are different. Okay, so you can see here that a colloid is a heterogeneous system in which one substance is dispersed as very fine particles in the another substance, which is called as dispersion medium. So basically it is like the same as in case of solvent and solute. Okay, that solvent is the one which is present in the larger quantity, and solute is the one which is present in the like smaller quantity. So in the case of colloids, it is one and the same thing, kind of, you can say. In this case, in case of colloids, it is known as dispersed phase and dispersion medium. Okay, see, as it is written here, it is heterogeneous in nature, in which one substance is dispersed as very fine particles. So basically it works as like solute, and in the another, in which it is dissolved, or you can say in which it is it is like dispersed, it is called as dispersion medium. Okay, so you can treat it as like solvent and solute in general. Okay, so in a colloid, dispersed phase may consist of particle of a single macromolecule, such as वो कोई प्रोटीन हो सकता है, कोई पॉलीमर हो सकता है, और लाइक ऐसे हो सकता है कि like some atoms or ions or molecules are simply just combined together. So a dispersed phase may be a protein, a polymer, aggregate means a group of atoms or ions or molecules, you can say. Okay, and we know that colloidal particles are larger than simple molecules but small enough to remain suspended, right? We know that. What are the three kinds of things that you have studied in your class 9-10? Colloid, suspension and solution, right? True solution, colloids and suspension. You guys have already done this in your class 9-10, right? Let me know, guys, if you have already like did this about colloids. Okay, let's move ahead. That is your classification of colloids. The next thing is about like how can you classify the colloids. So the very first basis is on the basis of like, see, first of all, like you can say there are 3 ways by which you can classify colloids. Okay, the very first is like the physical state, like what is the dispersed phase, whether it is solid or liquid or gas, and what is the dispersion medium. Okay, so physical state of dispersed phase and dispersion medium, this is the very first classification. Second one can be on the basis of the nature of interaction between the particles, between these dispersed phase and dispersion medium particles. Okay, and third one is the type of particles of the dispersed phase. So these are the points by which on which we can classify colloids. Okay, so very first is let's discuss first by the nature of interaction between dispersed phase and dispersion medium. So the very first one is Leophyllic colloids. The very first one is Leophyllic colloids. So the word LYO represent the word liquid, okay? It represent the word liquid. And philic represent, like you can say, loving, okay? You can say it is loving, okay? So the word leophilic, see, as it is written here, the word leophilic means liquid loving. What does it mean? That it loves liquid, okay? Colloidal sols directly formed by mixing substances like gum with a suitable liquid are called as leophilic sols, okay? In the next lecture, I will try to show you some of the like animation sort of stuff, so that you can just look at the pictures and you can get an idea like how like what are the different kinds of colloids which are present, okay? So an important characteristic of these sols is that if the dispersion medium is separated from the dispersed phase, the sol can be reconstituted by simply remixing the dispersion medium. That is why these sols are also called as reversible sols. What is a sol? Okay, see, the very first thing is on the basis of dispersed phase on the dispersion medium. So you are right, let's do it in that way first, okay? Just give me a moment. Yeah, let's see the first one, okay? Let's see here, okay? See, here on one end we will write the dispersion phase. You are right, we missed something, so let's cover it. It is dispersion phase here, and here we are taking dispersion medium, okay? Here we are taking dispersion medium, and according to it we will see what type of colloid will be formed. Type of colloid, and here we will see some examples, okay? Here we will see some examples. So if I tell you that my dispersion phase is solid, if I tell you that my dispersion phase is solid, as I told you here, that dispersion phase you can say is solute, dispersion medium is your solvent, right? So you can say when your solid is your solute is a solid, and your dispersion medium, that is your you can say solvent, is liquid. So what type of colloid is formed? It is called as sol. It is called as sol when there is solid in liquid, okay? For example, it can be like some kind of gemstones. Gemstones are some kind of examples, okay? Or like some colored gases as well. Next, so you understood what is sol, like solid when in, like it is in liquid. The difference between colloid and solutions is that is between the size of the particles, right? Let's look at the next one. If your dispersion phase is again solid, but your dispersion medium is gas, in that case your colloid is known as aerosol. It is known as aerosol, okay? And examples are you can say smoke is an example, right? Smoke is an example, or dust is also an example of like solid. Some, you see, if you see like a whole Tyndall effect, right? You see dust particles in air, right? So some solid particles are like in gas. So that is why you are saying that smoke or dust is an example of your aerosol, all right? Is there any doubt in this? नहीं, Suraj, let's do all of them now, right? Because I was thinking that I will let you know in the, like, after we discuss the second classification. But it turns out that if you don't know this classification first, there will be an issue in understanding the next classification, okay? Because like you asked already, what do you mean by souls? At least tell us now. So that's what you mean by soul. When solid is present in liquid, it is a soul, okay? When solid is present in gas, it is known as aerosol. When solid is present in solid, when solid is present in solid, solid in solid, we take that? Okay, let's take liquid in solid this time. Let's take liquid in solid. We don't take solid in solid. When you take liquid in solid, the type of a colloid it forms is a gel. You have seen gels, even your hair gel you have seen, okay? So it is an example of gel. Example, hair gel can be the example. Your butter can be the example. Your jellies which you eat, right? छोटे बच्चों के लिए आते हैं usually. So your jellies are the example. All right. Another example we can take liquid in liquid. Liquid in liquid you can take. In that case, the type of colloid which is formed is called an emulsion. What is it called? We will separately discuss about emulsion. This is very important. Liquid and liquid. We will discuss some properties of emulsions, and we'll do some stuff about emulsions, okay? That is in which your dispersion phase as well as your dispersion medium is liquid. It is called as an emulsion, okay? So what can be the example? The best example for emulsion is milk. We know na that milk is a colloid. So which type of colloid is it? It is an emulsion, okay? Milk can be the example, or like hair cream jo aati hai, that can be the example, okay? Is that okay, guys? Shaista, Suraj, we have some more as well. Okay, let's move ahead. We did liquid in liquid, right? Let's do liquid in gas. Next we will do liquid in gas. In this case, the type of a sol which is formed, it is also called as aerosol. Again, whether it is your solid in gas, even then it is known as aerosol, or it is your liquid in gas, it will be known as aerosol, okay? When you can say your dispersion medium is gas, it is known as aerosol, okay? What can be the example? Fog, mist, cloud, these are the examples. Fog, mist, clouds, these are the examples, okay? So is there any doubt till now? Yeah, right, exactly, Shaista, you're right, beta. Next, liquid and gas, aerosol. Next, what can we take? We can take gas in solid. When your dispersion phase is gas and your dispersion medium is solid, in that case, the type of colloid which is formed is called as solid sol. It is called as solid sol. All right. And what can be the examples? Foam rubber. Foam rubber can be the example. Okay. And the next one that we can take is gas in liquid. It is gas in liquid. Example, the type of colloid which is formed is called as foam. जैसे जो झाग जिनको हम हिंदी में बोलते हैं ना, foam, those are gas in liquid, right? Example can be soap lather, right? Or another example can be soap lather, and have you seen whipped cream? Whipped cream is an example. So we have done the very first classification. ठीक है, shaista or any type of froth, jhag, all right, gas and liquid it is. Crystal clear. Okay, that's amazing. That's okay. Shaista and Suraj, all right. I would just like to tell you, if like especially if this is your first class, then you can download Unacademy app, okay? I would love to meet you in the special classes. Like the very first thing is special classes are free, okay? You don't need to take any subscription for free classes, special classes. All right, so I would love to meet you all over there in this special classes. The only thing is you need to unlock the free live class. For that you can use my code, that is Kirti S Live. My code is Kirti S Live. Kirti is my name, S because my surname is Sharma, so that's my initial, and live because it is like a live class. All right, so I would love to meet you in the special classes as well, so that you guys will be, I would say, familiar with the platform. In order to see me, you need to select the category of ISC or class 11 or class 12, and there you can find me. Or you can just simply, like, when you register on the app, you need to search my name Kirti Sharma, you will find me. Or you can use it, my username, that is Kirti underscore Sharma 1223. Okay, yes, Shaista, Suraj, I would love to see you there. All right, that's amazing. Now, yeah, here we were. So we have done this classification. That was your first classification. Physical state of dispersed phase and dispersion medium, right? We saw what happened, like when this is solid, this is liquid, liquid, solid, gas and gas, right? We have done that. So let me know in the special class if you have any doubt. We have a special class on like after 2 days we have, because I'm not available tomorrow, that's why. Okay, so I would love to see you guys there. Next is nature of interaction between dispersed phase and dispersion medium. So this was regarding the second classification based on the nature of interaction. Okay, yeah, so it says the very first one is Leophyllic colloids and the other one is Leophobic colloids. In case of Leophobic colloids, they are liquid hating, and in case of Leophilic, they are liquid loving. All right, so now you understood what are colloidal sols, right? So colloidal sols, which are, just made by, mixing the substances like gum with a suitable liquid, and you just mix them, it is called as a Leophilic sol. Okay, 14/1 2022. What is this, Shaista? Is it, yeah, that would be the date of the session. Yeah, right. I really appreciate you guys, you're really cute, huh? Okay, and I would just tell you to, share the session with your friends, because a lot of people, a lot of students don't even know that this category is here now, that is your ISC category, and we are here. So help us to promote the, this motive, so that we can all grow together. Cool. So yeah, an important characteristic of these sols is that if the dispersion medium is separated, like if the, you can see here that if the solid and liquid, right, when your dispersion phase is solid and your dispersion medium is liquid, if these two are separated, say we separated them by evaporation, right? You evaporated the liquid so that only solid is left. So in case of Leophilic sols, what happens is, like if you get the liquid back and you simply mix them, then in that case your soul will be prepared again. All right. So this is what meant by the second point, which says an important characteristic of these sols is that if the dispersion medium is separated from the dispersed phase, say by evaporation, the sol can be reconstituted. It can be made again. How? Simply by remixing the dispersion medium. That is why these sols are also called as reversible sols. Is this point clear, guys? Is this point clear, guys? Let me know, please. Shaista, Suraj, let me know, guys, if this point is clear. Then we will move to leophobic sols, okay? And then I will let you know about some of the features that we have for you on Unacademy Plus. All right. Now the leophobic colloids are, as you can see, they are kind of opposite of leophilic colloids, right? The leophilic colloids were liquid loving and these are liquid hating, okay? Phobic means you already know, right? We always say that I have, say, a phobia of height. Say somebody has a phobia of height, means that person is uncomfortable at heights. So similarly, these are leophobic, okay? Whenever they are around some liquid, they feel uncomfortable, okay? In this manner you can understand. So substances like metals, their sulfides, etc., when simply mixed with the dispersion medium, they do not form colloidal sol. Alright, their colloidal sols can be prepared only by special methods, okay? In case of some metals and their sulfides, the colloids can be formed by some special methods, right? Such as coagulation or peptization, alright? So there are some special methods. We will see in the next session what are those special methods, okay? Meanwhile, you can just join the Telegram group. The description is given in the link is given in the description box, and you can join it so that you will get all the notifications regarding the YouTube lectures. All right. Yeah. So such sols are called as leophobic sols. These sols are readily precipitated or coagulated on the addition of small amounts of electrolytes by heating or shaking, and hence are not stable. The leophilic sols are very stable. These are stable, okay? And leophobic sols they are not very stable. They are unstable, okay? You will understand what is meant by peptization, coagulation. We will do everything, no worries. Further, once precipitated, now if like these sols get precipitated, they cannot be formed again, okay? So they are irreversible in nature. They do not give back the colloidal sol by simply addition of dispersion medium. Hence these sols are irreversible sols. ठीक है? Apart from it, now we will do from here macromolecular colloids in the next session. I would like to tell you the features that we have for you for Unacademy Plus features, okay? Yeah, here it is. Unacademy subscription features. So you guys already know that there is now an outbreak of COVID again. So it's better to just I would say just to stay at home and learn live with the top educators of India, okay? And only at the Plus platform we cover 100% of the syllabus. We cover 100% of the syllabus, okay? There is like an exhaustive coverage syllabus, I would say. So, and if you subscribe to one category, you can access all the courses which are available. You can enter in any batch. Like you can study from your favorite teacher, and there are like regular doubt solving sessions. That is, every fourth session, it is mandatory. Okay, it is understood that every fourth session in the plus session is a regular doubt solving sessions, in which all your doubts will be कोई बात नहीं सूरज बेटा, you can watch it in the recorded form in the replay, right? And if you still have any doubt, let me know in the next lecture, okay? So yeah, I was telling you about some of the features of Unacademy Plus. So if you subscribe, we can cover 100% of the syllabus together. It is like an exhaustive coverage syllabus. We give you mentorship, guidance, all the material is provided to you in the PDF form. There are regular practice tests, live tests, batch courses. So a lot of things are there. Yes, beta, the session has almost ended. I am just telling you about the features of Unacademy Plus now. If you subscribe, you can learn live from us on the Unacademy platform, and there we cover 100% of the syllabus. So it's like amazing feature for you, okay? You can see here, here are some plans for Unacademy Plus subscription. And as I always tell you, to get the subscription for a longer period of time, so that it will cost you lesser. And after applying my YT code, while getting the subscription, you will get additional 10% off, okay? The batch is getting launched on 17th of January. We will cover all your syllabus of term 2. It is your crash course. So join it now. Thank you, Shaista. I really appreciate it, beta. Okay. Let's meet in the special session. Then I believe you will definitely join the plus session as well. Okay, because only at plus platform we cover 100% of the syllabus. These are the batches which are going on. And right now, right, ISC board, Suraj. Okay, so I would love to see you. And there is some amazing offer which is going on these days, and that is, if you get the subscription for class 9, you will get the subscription for class 10, 11 and 12 for free. If you subscribe for class 10, you will get class 11 and 12 subscription for free. If you subscribe for class 11, you will get class 12 subscription for free. So if you guys are in class 12, right? So instead of getting the subscription for class 12, you guys can get the subscription for class 11, and you will get the class 12 subscription for free, so that you can attend either of the two sessions, okay? It costs you the same. And if you take the subscription for a longer period of time, say or 12 months or 18 months, and then you apply the code, that is Kirti S Live, then it will be very economical for you. 100% of the syllabus will be covered in around 500 a month, okay? 500, 600 a month, I believe it would be. And you can cover your 11th class 11 syllabus, class 12 syllabus, physics, chemistry, maths, biology, all these 4 things in such a nominal price, okay? So get the subscription now. I will wait for you guys in the plus courses, okay? The batch has already been started. We have already covered, I guess, 1 chapter already. So don't be late, okay? Join plus right now. It is a must for you. And again, as I told you, there is outbreak of COVID. So it's better to stay at home and learn with top educators of India, right? So download Unacademy app right now, and let's crack it. Okay, you guys can find me on Telegram or Unacademy Messenger by this username, that is Kirti_Sharma 1223. This is my username. Okay, so you guys can be connected with me. So that is it for the day, guys. All right. If you have any doubt, any query regarding lecture, regarding special sessions, regarding plus sessions, then let me know. I will help you. Let me know, guys, if there is any doubt. And this is it for the day. Okay, join the. Thank you, Beta. I really appreciate this. Okay, I'll wait for you in all the further sessions. We will rock together. Okay, and explore for plus subscription. Believe me, there we will cover 100% of the syllabus and it will be a lot more fun. Okay, so guys, tell me if there is any doubt, and if not, then we'll meet in the next sessions. Bye Suraj, bye Shesta, bye bye. It was an amazing experience with you guys. Okay, so I'm ending the session now. Bye bye.